You ready? Cool. Good afternoon, everyone, and welcome to our last session today, which is winning with a data-led strategy. So thank you very much for joining us. Hope you've enjoyed today's session so far for our first UK Construction Week online. This platform is now going to be live for the rest of the year, so you can have a look at the content on here, and also, most importantly, perhaps go and have a look at the new products and services and available on here from our exhibitors. Today's session, we're going to be talking to James in a minute, and you can ask questions at the end of today's session. So if you want to do that, if you use our live discussion boxes, and I can put your questions to him at the end. So please do that. And if you want to visit James and the Sensat team afterwards, then please look at their profile on the exhibitor page. You can see case studies up there, and there's all sorts of other information around Sensat, and you can book meetings with the team. So video calls or whatever you want to do. So that please use that. So on to today, and we're talking about winning with the data-led strategy. So civil infrastructure is one of the most least digitized industries in the world today. Many industries have obviously adopted digitalization very quickly, and there's a huge opportunity for construction to catch up. So I'm really delighted that James Dean, Sensat CEO, is going to talk to us today about how visualized data can promote offsite construction, how it increases efficiencies, improves productivity, and can lead to sustainable decisions. James is a technological entrepreneur, and he was a former NASA satellite engineer, and he was fascinated by how the world works. So he founded Sensat in 2017, perhaps with some of those thoughts in mind, and how perhaps he could use those to transform the construction sector. So, James, welcome. How are you?
Very good, thank you. I was just thinking that picture's definitely pre-COVID, isn't it? Not aged well.
Well, I'm not going to comment, but you should have seen some of the webinars I did during mid lockdown. So yeah. So welcome, James, and looking forward to hearing your talk today. As I say, people want people to ask questions as well, so do use those boxes. But I'm going to hand over to you.
Great, thank you. Pleasure to be here this afternoon. Thank you for waiting around a couple of minutes as well. When we originally talked about doing this session, we wanted to kind of build on this theme of winning with a data-led strategy. And I guess like what we mean by that is that we in this industry at this period in time are probably living in the most exciting time to work in civil infrastructure. There is so many new technologies coming online. There's so many exciting projects that we need to build. It's an exciting time to be alive, to be frank. And what we wanted to talk about was actually how we could have a playbook for winning with that data-led strategy, incorporating data into what we do day in, day out to make sure that we are really delivering those projects the best we possibly can be. However, I was kind of thinking about it a bit deeper, and I thought, instead of me kind of talking you through ideas and concepts and why this matters, I think it's going to be more effective for me to actually just tell you a story, talk about a customer of ours that is winning with a data-led strategy, and how this can influence projects at different stages of the asset lifecycle as well. So Nathan, I'm going to share my screen. I won't be able to see you once I do, so do you mind just telling me if you can see it okay?
Yeah, that's all good, James, all good.
Perfect, thank you very much. So I wanted to talk today and really focus on how work we've done with WSP and Network Rail has really kind of led to fantastic outcomes and a really good exhibition of using data as part of the process for actually in this stage optioneering and feasibility studies, but actually can take these lessons and apply them not just to the rail industry, but to large civil infrastructure in multiple different phases as well. So this is actually a project which we started working on with WSP back in 2018, believe it or not. So a couple of years ago, and this is in the Ely enhancement area. So just for a bit of context, around Ely, you've basically got 5 different rail lines coming into the Ely area, and all those rail lines are at capacity right now. So essentially, there is no more room for more services to go in these areas. And that's a problem. Obviously, we're adding a lot of network traffic, we're adding a lot of demand. We want to add more capacity to this Ely area where these 5 junctions come together, so we can start to think about increasing train capacity over the next kind of decade or so. So that's sort of the backdrop for kind of what we're doing here. And when we started to work with WSP originally, they came to us and basically said that we have this issue because we have these constraints. We've basically been brought in at grip too. we're looking to basically provide master planning and option layering for basically how we can add capacity to the network in this area. However, we have certain constraints. It's a very large area. There's a lot of traffic on the network, and basically we need to kind of think about how we can do this in a more robust, modern way from kind of the traditional techniques we've been using. So the goal basically at that point was to leverage modern technology to really provide best-in-class master planning at GRIP 2 and going into GRIP 3 for Ely on behalf of Network Rail, reducing program risk, providing industry integrated schedule as well. So that was sort of the goal as we kind of set up ahead of time here. And looking at Ely specifically, it's really quite an interesting problem. Now, it's not a problem that's unique by any stretch of the imagination, but it's a problem which is often faced and often similar, but plays itself out in maybe some slightly different scenarios. So specifically for Ely enhancements, you've got a very large area. So to start off with, we're talking about 6.5 square kilometers of area. And this part of the network, as I've mentioned, is already at capacity. So what that meant was, like, in the first instance, we need to go and conduct surveys. And actually traditional surveys would have required track possessions for about 10 weeks of time. It wasn't possible to do that. There's significant stress already on the network overloaded capacity. So closing 10 weeks of track time, actually putting boots on the ground to go survey the areas, it was really not an ideal kind of option. The second problem was that the sheer scale of this area encompasses about 30 miles of track and about 40 level crossings, really create like logistical challenges. Now that kind of plays out from everything from how do we get physical land access and permissions to do that, to providing RAMs, risk assessments, and also actually prioritizing work in the order that we need it for optioning and feasibility at these stages as well. And then finally, there was really no clear way to kind of collaborate and share information effectively between stakeholders. Those stakeholders, were far wide and ranging. It went everywhere from Cambridgeshire Council to Network Rail sponsor teams to actually the engineering design teams, all the way through to kind of local communities as well. So how do we bring them all together to effectively share this information? So together, basically, we designed a data-led strategy, and this essentially came down to kind of Sensat's core product set in this instance. And it basically combines two emerging technologies to help overcome these challenges. So on the first side here, on the left, you've essentially got what we call kind of modern or tech-enabled survey techniques. So in this specific instance, that meant recreating the 16 square kilometers using autonomous mapping drones. So these are almost like small planes, flying about 80 to 120 meters, and just flying back and forth, effectively imaging the whole area like tens of thousands of times, and then reconstructing that imagery together to build this 3D topographical survey of that area. That was accurate to about 35 to 50 millimeters. It was kind of RIXBAN D, RIXBAN E in different areas. However, because it's rail, we need some areas with much higher resolution. So we actually looked at how could we source, third-party track LiDAR as well, which we bring in. So we worked with Fugro on their RILAS data sets to bring in, I think, about 5-6 mil accuracy LiDAR data. And then also some areas need ground-based investigation. And by starting off with the wide area survey using the drones, we could really quickly and really specifically target certain areas where we needed further investigations. So it's a really interesting kind of way of doing it, because before we'd have created a bit of a does everything specification for surveying, include the entire topography, go and measure everything. Whereas now what we can do is measure everything very, very quickly, and then actually go and do infill in certain areas where we need higher accuracy as well. On the other side of that, you've got this is a tremendous amount of data. I think at this point, about 170 gigabytes of data being collected. How do I bring that together? How do I make it accessible to different people? And this is where technology is really kind of coming to the fore. And this is where Sensat building specific technology for the purpose of bringing very large information sets together and giving people the data from which they can make these decisions. So this is a platform we've developed. We've developed actually in conjunction with our customers, taking that input and actually having our team develop on the back of that. And this platform had, I guess, a couple of different features which were really novel. So the first one was unlimited users. We wanted to make sure that everybody that needed to access it could access it. We didn't want to kind of put blockers in place by charging on a per seat license basis. Secondly, we wanted to make it available on any device. So you didn't have to have a supercomputer sat in the office. Actually, no, you could go on your tablet, you could go on your mobile phone, you could go on your work laptop and actually start to access the site remotely, access the site from wherever you are, quite frankly. And then the third thing is really adding that context. So not just seeing the BIM designs as a 2D drawing, not just seeing the survey information as 2D drawing, but bringing all of this information together in 3 dimensions and allowing us to basically understand the context, which really translates at this stage of the program into what are the constraints that we're working with, as we go through optioneering and feasibility. So a real quick note on the mapping drone. So I cannot remember exactly how long it took to complete those 16 square kilometers, but Network Rail just extended this all the way up to Ipswich as well. And I think basically within 2 weeks of saying we want to do this, the design teams now begin to have data to work with. So we can actually start that downstream process very, very, very quickly. I believe the entire area probably takes about 7 or 8 days. I know last week we've actually just completed the entirety of HS2's phase 2A route. It'll be the largest drone mapping job in the world. That's about 55 square kilometers. That took the team 8 days to deliver that. So an incredible amount of speed to get access to this information. And having that much earlier on in the process is really, really beneficial. So how does this work? You can kind of see if I zoom in very slightly here, you can see almost like the drone here. So this is the flight control software. It's almost like a little plane, as I mentioned. And it's literally flying backwards and forwards, backwards and forwards, backwards and forwards, just taking thousands of images to the ground. Actually, in kind of the flying backwards and forwards, we actually completed a survey of the entirety of the M25 last year. At the time, I think that was the largest drone mapping job. Across the 186 kilometers of the M25 circular, that drone covered about the same equivalent distance as London to New York. So incredible kind of amounts of distance which we're covering here. All done completely safely with no traffic management, nobody actually putting any boots on the ground. So very, very incredible like how this technology is coming to the fore. And essentially, whilst it's flying, we're tracking it. It's connected to a number of satellites, normally about 15 to 20 different satellites. And they're providing something called an RTK GNSS fix. So what that means in kind of English is essentially we know where that drone is to about 15 to 20 millimeters at any point in time. And therefore, those images become geolocated, that information. And then we can process that into these accurate representations that we come to later on as well. So really, really exciting to kind of see it through those perspectives. The benefits really, and I'm going to go in and show you this live in a second as well, so you can actually explore it a bit more. But the top line benefits were that working together with this data-led strategy basically meant we could begin to overcome like significant constraints that we had on this project. So the modern digital surveying approach really reduced capture time by about 95%. So instead of us waiting about 6 to 7 months at best to get that information to begin work, we could begin within a number of days. I think it was about 10 to 14 days. And in the era of project speed, in the era of actually getting to decisions quicker, when the focus really comes onto this is where that data-led strategy and actually prioritizing that data up front helps us make quicker decisions, but much, much better informed decisions as well. And this is increasing certainty, it's reducing risk in the program schedules. So the benefits here are no possessions, no boots on the ground, and multiple reusability of that data. I'll come back later and talk about this, but it's really, really healthy to actually look at getting these data sets up front in the asset lifecycle because they have multiple downstream benefits as well and pay for themselves many times over. The second benefit here is we briefly touched upon is by standardizing those surveys, we actually now have this source of truth and it's very encompassing as well. So this reduces program risk, it eliminates land access requirements. I had a customer that I spoke to a couple of days ago and he said, we once had a survey done of a building. It's a large building on our land, our portfolio. And they're doing I think it's about 3 billion regeneration in this area. And they said this building, which is like a large warehouse type building, so it's not something you can really miss. Their plans originally had it out from the location it was by about 100 meters. Now that tells me there's just some sort of surveying error. Someone's made a typo or something and it's come out. When we investigated it and using our data to basically provide this all-encompassing kind of reference check, if you like, we actually worked out that it was out of position for where they thought it was by about 7 meters. Okay, not as bad as 100 meters, but actually 7 meters, if they did not pick up on this, meant that they'd be breaching their planning controls around actually how close it was to a road and the developments they put into place. So this is the kind of thing where you start off with high uncertainty, high risk, and having this data actually helps you uncover problems which you might not find until much later down the program. And in that instance, actually, if that program had gone unnoticed, if that problem had gone unnoticed, that would have cost them tens of millions in moving either the road or that big building, equal of which we don't want, and that's multiple years down the program, so much harder to kind of recoup at that time. So really the benefits there are, that high quality and everything in one place allows you to be much more directed, much more confident and have much more cohesion in terms of the survey strategy of what's actually there. How do we reference this? And then the third thing is really the platform that we built. At this point, I think we brought together about 160 gigabytes of program data and made it accessible to all the stakeholders, obviously those that were given permission. And that in itself seems like almost quite a simple statement, but how often do we actually get that amount of data? We can open it, we can look at it, we can use it, and more frequently we actually can share it with people. I have a funny story I often tell, which I won't name names, but I remember being on a smart motorways project once, and we wanted to look at some of the BIM designs for some of the gantries they're putting in. And we said to the BIM manager, "Oh, can we open them up?" And he said, "Oh, I don't have them." And we're halfway through a 250 million scheme. And we kind of said, a little bit puzzled, "What do you mean you don't have them? You're building this thing. How can you not have access to the BIM designs?" And he said, "Oh, well, the designer's got them and they've not been able to release them to us because it's a different file type. We don't have that software." He said, "Okay, well, cool. Who's the designer? Where are they?" And it's like, "Oh, the guy sat over there." And he kind of pointed to the back of the porter cabin. This guy sat over there. And 12 months into this, 250 million pound scheme, they don't have the actual designs of what they're building, the BIM formats, because they don't have the right file type. And you kind of it's puzzling, but it is the reality. And you know what, we put up with too much pain on a day-to-day basis. So how can we bring this information together? How can we work from the same kind of set of information? How can we make it accessible to all stakeholders? I personally believe there's a lot of power in doing that, and in kind of making this thing available and actually kind of democratizing that information, obviously where appropriate within kind of permissions. So this is not exactly apples for apples on Ely. For reference, Ely is about half the size of the Heathrow expansion. But when we worked on Heathrow expansion, we did actually quite a lot of work to build that business case and then measure the ROI, the return on investments, and those tangible kind of cost savings that we had. So Heathrow came back after basically doing a very similar thing to what we're doing here with Ely, and said we saved them around 100,000 man hours and around 20 million in direct project costs. That's incredible, 100,000 man hours just from using a data-led strategy, just from being more informed upfront. And that resulted in direct 20 million costs and probably indirectly many, many more millions on top of that. So Ely's pretty much about 50% the size. So you could kind of argue, around 50,000 man hours and 10 million of direct costs. And these are the kind of goals we should be striving towards and happy to accomplish as well. And actually, we'll have a look in about a minute's time at the actual project itself. But this really helped because they could integrate all their CADs. They could integrate all their BIM data. They could actually begin to view these different options in context of what's there. Even at the optioneering phase, we're recording around 20 virtual site visits a day. I think this is really important. We've recently gone through the HS2 accelerator and have been working with HS2 on actually looking at business cases for remote working. How can we cut people traveling to site where it's just not necessary? And often actually we find that site visits don't require as many people or even sometimes to go there physically if you had something like a digital site replica. So in the instance of HS2, we calculate actually the business case is about 65 million pounds a year on actually just saving people needless visits to site where they could have done this work remotely. So even on Ely here, you're getting about 20 virtual site visits a day where engineers are going in from wherever they are. It's an interesting statistic to kind of track actually where they are, but going into Cambridgeshire from London, from Edinburgh, from the Bristol offices, from the Network Rail offices in Milton Keynes, and effectively visiting site without having to drive there, without all the pollution that comes with that, but actually being able to kind of work on these sites virtually is very, very important and definitely is the future as well. So I'm going to jump in and actually just kind of demo this and show it. I apologize because I think we're going through Zoom to YouTube to potentially somewhere else. So it may be a little bit laggy just because it kind of comes through here, but it's not on my screen. So what time are we on? 24, great. So this is the Ely area. So this potentially doesn't look that big. This is about 16 square kilometers. So a huge amount of data here. Just to put that into numbers, this is probably around, I'm going to guess around 3 billion data points of individual data points making up to this data set. So this is not small by any means of imagination. I can say hands down, there's no way you could open this on your local computer. So this is the platform I was talking about. Essentially what we have here is cloud-based. So in effect, the technology is a little bit like Netflix or BBC iPlayer. We host the data and we're effectively streaming it back to you. So you can access it from wherever you want. We effectively have a supercomputer in the cloud and you can basically gain access to this as well. So if I just turn this down for a second, we can have a look at it. We'll have a look. We'll fly over to the Ely Cathedral so you can kind of, it's quite nice to have a look at that here. So just load in. And so part of the optioneering phases is, okay, well, let's have a look at kind of the cathedral, let's have a look at the surrounding area and actually have a look at, where these different options look like from different kind of angles here as well. So I'm going to turn that back off and put this back up a second. So the first thing to notice is just how responsive this information is. So it's a little bit like Google Earth. I've heard this kind of talked about as Google Earth on steroids. And essentially you have this huge area, but you can zoom right in here and get point cloud data, which is engineering grade, as I mentioned about RIXBand E, basically to start to measure things, to understand things. So a popular use case for this has actually been creating cross-sectional profiles, which the designers are able to kind of then use for generating certain things. You can also do that by actually going in, creating annotations. So we could go here, for example, and say there's a missing calvert. We could share that with certain team members and make it visible to the project. We could mark it as red, so it's a red risk, for example. And what you're also creating is those X, Y, and Z coordinates. In fact, when I'm talking about actually digitizing the world, building these digital records, this modern view of surveying, what we effectively mean is we're doing the exact thing that the surveyor would do. We're going around, we're taking a measurement using a GNSS and a measuring stick. But apart from physically walking around and taking those measurements, we're essentially using this new remote sensing technique to take, literally tens of millions, in this case, billions of these measurements. So it's quite difficult to see here, but you might be able to see that each of these individual little dots basically represents an X, Y, and Z 3D coordinate. And each one of those basically, if we put millions of them together, we start to build this digital representation of what's actually there. And those dots with this data set are accurate to about 25 to 30 millimeters. So once we have this information, we might also want to add other types of information. I'm zooming in and out here, so it might be a little bit jumpy if it's laggy. I can't see it on your side, but so if we go in here as well, we have other data sets. If I just turn that down, I mentioned that we wanted to bring other information into this as well. So this is an example of that RILAR track data. If I bring those two in, so you can see that's loading in here as well. So this is looking at about 5 millimeter data. Actually here you can see that we can start to bring for the first time the actual overhead lines as well. So that's just a bit more accurate. That's required for the track side things. But we want to verges in other areas. It's better to use the drone data. And actually, if I go all the way up to this other end, let's turn it off a second. We have how they can bring other survey data into this as well. So actually over here, we've got these boreholes. And these are the borehole reports actually coming in from Bridgeway. I believe Bridgeway Consulting in this instance, and actually showing what is the ground made of and actually what's the results in those geotechnical investigations have done as well. So the idea really is how can we bring lots of different types of survey information together to give us that holistic view? How can we do that much quicker? How can we use this to actually target the certain areas we want to find information and start to use that information together to better understand and make better, more informed decisions and kind of bring this to on these options as well. So if I give you an example of this, if we go in down here, so this is where one of the two lanes basically come into kind of congestion together. So the proposals here, or one of the options which we're looking at is basically, can we remove the green items? We go down here, you can see some of them. Can we remove the green items and can we actually put in the red items as part of the engineering? So by doing this really quickly, we can do two things. The first thing is we can have a look at it, we can see it. And I know that sounds, pretty basic, but it's amazing how many people come to me and say, James, I just was able to solve the problem because I could see it. I could look at it from different angles. I could look at what the options were, and I could really kind of engage bits of my brain, which were hard to do when I couldn't see the thing before. So don't underestimate that. It's really valuable to actually just be able to see this information for the first time. The second thing was then actually they're able to engage the TOCs and FOCs, the train operating companies, and the freight operating companies to start to do like really early signal investigation. So again, I imagine this is a bit laggy going through YouTube, etc. But you can see essentially how you can essentially just fly down the area here, you come into the station area, look at what the signaling looks like, and actually just look at those options much earlier on. So it's very interesting to see basically how these new use cases are effectively coming together and looking at these sort of things. If I just fly over here to the other side of Ely, one of the examples here was we wanted to remove a level crossing. Level crossing was essentially slowing us down. We wanted to have more capacity. However, if we look in this different area, and if I just turn this down again for a second, we can see that actually these areas here are identifying SSS sites, so sites of special scientific interest. So this is interesting because we can start to understand the constraints that we have. In this instance here, we've got an industrial estate down here, and the industrial estate is accessed by the road that goes over level crossing. So what can we do? How can we reroute this? Do we need to reroute it? What different options do we have to kind of bring this in place? And actually underneath this, actually what WSP are doing is actually doing their designs using the Bentley suite. So they can bring all those Bentley files into here. And as you can see at massive scale, you can put them into context of what's actually there using the survey data, even though they're like proprietary Bentley formats. We built in ingesters and indexing for all these different file types. So essentially, it's as simple as you come in here, you upload the data. Our algorithms basically crunch that data, make it so you can view it in the browser, but also adjust the coordinate reference systems to match as well. So you're always working with engineering grade data as you kind of start to bring this in. I don't have the example in this one, but there's also a full 2D environment. So think of your Google Maps, your kind of Google Earth and your GIS systems. So all of this information, which is sitting in 3D, can also come into that 2D environment as well. The final thing I wanted to kind of just mention is that kind of collaboration points, the ability to come in, begin to collaborate within context of what we can see, begin to collaborate within context of what's actually there. And this is sort of now extended to the point where it's not just this massive Ely area, but we're actually adding data for a lot of the East Anglia sections as well. So you can see as we go all the way up here, and this is actually heading all the way up to kind of Ipswich. So it's really, this is just information going in the last kind of couple of weeks, and is really helping these engineers unlock this data very, very quickly. And who wants to make a guess how far we are here from where we started in Ely? There you go, 27 kilometers away. So just the ability to come in, measure the world, make these zones, understand, how big the field is in like a matter of seconds from wherever we are in the world compared to actually doing those things by physically going there. It's just an incredible, step forward for how we build and kind of run civil infrastructure like this as well. So just to quickly wrap up, so I want to save some time for questions. Irrevocably, this is cheaper. It is so much quicker. I think it's about 95% equals about 400 times faster. We don't put anybody on the track. That was a big point, actually. I think when I met Network Rail a few weeks ago, unfortunately, somebody being killed at Waterloo. And, fortunately on the Ely project, no one has been killed. But a big part of that is because we're proactively taking people out of harm's way. And I think that's such an important point, which actually is worth laboring. We're adding this context, which means we can get to decisions faster, we can manage stakeholders. And really crucially, we have communication. We have open lines of communication, looking at different ways we can use this information, being data informed, being data led. And really what WSP is doing here is connecting people with the data and the decisions. And this is setting a really strong foundation for the rest of the Ely program lifecycle. So we're still in, I think we've just moved into feasibility. We still have engineering design, we have early contracts involved, and we have construction, and then it's going to be handed over again for maintenance. So this is setting a really good foundation for the rest of that program to succeed. This is an interesting slide, and if anyone wants this in detail, because I appreciate it's quite heavy, please feel free to just drop me a note or an email afterwards, and I'm happy to share this with you. But this is really looking at the broader asset lifecycle and how we can use this data as that foundation going forward. So at the moment here, we're in the options phase. So we're at GRIP 2, and we've got Network Rail, we've got WSP. And basically, if you look underneath this, there's a whole set of tasks or things we have to do. So project setup, design data validation, planning and scheduling, cost planning estimation, environmental sustainability, facilities management. And each of these boxes are a task, and at the moment it really represents a different data set or a different software that we use. So one thing I've really experienced is that this industry is not short of information. It has it everywhere, but it's incredibly fragmented, probably the most fragmented I've ever seen, actually. So what we're trying to do is actually bring that information back together. We call it a common visualization environment. It's attached to the common data environment. And it's helping us to just bring that information back so people can begin to use it. People can begin to kind of collaborate on it as well. So that's kind of setting the program up for success over the next couple of years. And that is basically kind of a good story of, a client winning with data-led thing. And it'd be good to take any questions in the last 10 minutes.
Brilliant. Thank you very much, James. That was fascinating, especially as a former geography student as well. So thank you very much for that. I think, obviously, digitalisation has probably leapt on leaps and bounds in the last 12 months across every sector, but construction perhaps more than most. So have you had a busy 12 months this year? Have you noticed an increase in the amount of people seeing the value in in coming to you for data-led projects?
So technology follows a pretty well documented adoption life cycle. So you start off with visionaries, then early adopters, and then basically the early majority, the late majority, and the laggards. So it's a little bit like a bell curve. It's documented in everything from LCD TVs through to Teslas, even through to kind of what we're doing as well. So typically the people who are, I'm pretty guessing, joining this kind of, this discussion today, they're going to be the visionaries and the early adopters. And what happens is the laggards aren't going to, buy until the late majority buys, they're not going to buy until the early majority buys, and so on and so forth. So I think what's happened over the last 12 months is that curve has begun to move. So whereas you've always had people, and like often you'll find people saying we were doing these types of things 20 years ago, we were. But two things are happening now, two big structural changes. The first one is the technology is getting really good. And that's actually allowing it to be deployed and be useful and actually find business value straight away. And I think that's so important for you moving through that life cycle. The second thing is that the structural issues around COVID have forced us to think, how can I do this better? Now, there's a bit of a saying, if it's not broke, don't fix it. What we have been doing for the last 6,500 years is not broken, it works. And we know what our risk appetite is, we know it can deliver for us, we know how it slots into a program schedule. It's not broken, but there's a way to do it 10 times better. And I think what this is forcing us to do is look at the way we can do it 10 times better. And that's what's kind of the two things which are pretty exciting, and why I say that this is really the most exciting time to be working in this industry.
Brilliant. Yeah, no, we've got that feeling today actually through a few of the sessions that we've had. So the other thing I was going to ask as well is, in terms of someone who's mid-project, how often do you get people coming to you and saying, actually, we need your help? And is that even possible?
I can 72% of our projects or our deals at the moment, if you like, are done in project. So actually, it's something's gone wrong. We need to solve this pain point. That's good because it shows that we can come in, we can basically solve the pain, we can use it, and people come back and buy again. However, to mature as an industry, we want to make that actually a small amount. So we want to be using this from the offset. It's no good actually having the problem and then trying to fix it. It's better actually to take those learnings, put it into the next projects we're having. So yeah, I have that number to hand actually, because I was looking at this morning.
Brilliant. Okay. And so how, I guess, how quickly could someone see, how quickly can you make an impact if you're coming into a project that's already, as you say, quite often you're coming in midway through?
Yeah. Typically within 2 weeks. Massive projects like EV maybe a little bit longer, smaller projects maybe a bit faster, but I'd say the majority, 80% plus, within 2 weeks. How it happens in practice is we basically would work together to figure out what is the problem statement, what are we trying to solve, and then it's not always the same solutions. We might say, actually, this is the best way of doing it. We recently did the M23 smart motorways, and it wasn't about flying drones, it's about driven LiDAR. So actually, how can we use this kind of tool set of modern surveying techniques to build these reality replicas? So we will advise on that and basically kind of produce that, and then we can quickly get the data. And then really within hours of getting that data, you can start to onboard team members, probably fix the initial issue you had, and then start to kind of go through the motions of actually seeing what else can we do with this? How can we bring more data in? How can we bring our design data in? And begin to collaborate as well. And I'll tell you as well, like, it's fascinating from my side to see how people use this, the kind of use cases they come up with. It's just incredible, really, actually.
Cool. And what do you see the future holding? I mean, what kind of technology is coming that's going to change again how we use data? What's the big advancement we're going to see next?
Okay, two things then. So 5G becomes an enabler for bringing real-time information in. So whereas that was patchy before, 5G completely overcomes that situation. So we're working on a piece of work at the moment with HS2, and the idea is to replace the engineer's eyes with cameras. So we put cameras, video cameras, basically around the site, and then we use machine learning to spot what the cameras see, and then we place them back into that 3D replica we had there. So if you imagine there's a site and we've got some excavators working, we're actually building that record almost in this virtual sim city of who's there, who's working, what they're doing, not the individual name of the person, but hey, there's an excavator here or people here. And what that starts to do is build up an incredibly detailed automated assurance record. So when we're going back for claims, when we're going back for disputes, we have really high supporting evidence. So speaking to a customer recently, and their claim renewal rate or the claim success rate was about 30%. And I said, okay, well, what's the difference? Why is it not 100%? He said, well, there's two reasons. Either we're making up the claims and we're being kind of dodgy. It's not the case because we work with these clients day in, day out. Or the second thing is that we just can't evidence or support those claims to enough extent where they're going to get approved. This will completely undo that because now you have hard evidence of exactly what's happened, and then we can begin to run analytics on that. And I think what that will mean is that we'll go through a phase of using this to sort of produce claims and blah blah blah, and that's takes a lot of headaches off some people. But we'll then start to look at the data, and we'll start to figure out that my construction company is profitable in these areas, and actually therefore I have a risk tolerance for bidding these jobs. So we'll start to see more specialisms come out and actually margins increase as people can use this data to actually build very, very solid businesses going forward.
Okay, and so last question before we wrap up for today. But just thinking, we've spoken tomorrow. We've got a session on what the CLC are doing around net zero, and you mentioned in your presentation around how how using data you can protect areas of special scientific interest and so on. What's the sort of what's the key ways in which data can help us make sure that major infrastructure projects are net zero in the future?
So sustainability is a really key part of our mission. It's really the why we do what we do. I'll be honest, like our customers don't buy for sustainability purposes. They buy for safety, quality, cost, time purposes. I'm hoping in the future we will buy for sustainability purposes as well. However, we believe that we can have that impact by building good business and products that people want, which then impact that as well. So it's hard for us to quantify the total impact. So we started off by doing two. So the first one we wanted to look at is earthworks and projects where we work on where there's mass haul. Actually, if we can remove the guesstimation and double shifting of soil, that has a big impact on carbon. And then the second piece is actually, to a lesser extent, people visiting a site remotely rather than having to actually physically go there. So we calculated actually, again, a number which is just in my head for some reason, but last Friday we calculated that over the last year, just in the last year of projects, we've saved about 5.5 million kilograms of carbon. To put that in perspective, that equates to about 33,000 trees worth of carbon ingestion per year. And these are only baby steps, and the impact is sure to be much bigger than that because that's only the things we can really tangibly calculate. So I think these are the kind of ways that actually you can use technology to almost inadvertently have those sustainability impacts by having less guesstimation, more quantified information, and being able to work in a futuristic way where we can work remotely.
Brilliant. Okay, thank you very much, James. It's fascinating stuff, and yeah, really exciting kind of to hear the opportunity, really. And as you said, I think you started off by saying there's never been such an exciting time to be in the industry, and a lot of what you've talked about hopefully can be useful in getting others to join in the next years as we need more people. So yeah, thank you very much. So James, I don't know if you're going to be around on the platform. I know your team are for the next day or two as well, so people can, the case study, I think someone shared in the discussion as well, so people can take a look at that, but also on your profile on Swapcard as well. So thank you very much for that.
No worries, yeah, we'll be around, and yeah, find me on LinkedIn or something if anyone wants to chat specifically. Brilliant,
good stuff. Great. And yeah, well, that's pretty much finished for today now. Obviously people can still meet on the platform, they can still have video meetings and all of that, but we're back tomorrow with we've got the CLC talking about net zero. That's a really important session with Andy Mitchell from Tideway, as well as some champions that are leading the way in that, big construction companies, big contractors, but we've also got more CPD and debate. So brilliant, we'll look forward to seeing everyone tomorrow. All right, thank you very much.